Hello and welcome to this webinar. My name is Vincent Lussenburg. I'm a technical product manager with Backtrace, and today we're going to talk about how to resolve mobile app errors, crashes, and hangs before your app store rating suffers. And also we're going to talk about why you would care that your app store rating suffers. So let's take a look at the agenda first. So I'm going to start by talking to you about what the cause is of bad app reviews, at least what it can be, as well as what the impact is. And the other words is why should you care? We're going to take a look at how to cut your error resolution time in half and how that is related to your app reviews. We're going to look at a demo on how to integrate Backtrace crash reporting library into your mobile app, and as well as how to use Backtrace to prioritize and to resolve issues that you might find. And finally, we're going to do a Q&A. What's not on the slide, but what is in front of you, if all is going well, is a poll. This poll is asking you throughout basically this entire presentation on basically one question, and that is how you capture your errors today. And during the Q&A, I will talk about what kind of responses I got, what I typically see. So that'll be fun to take a look at. So please, if you can fill out that questionnaire or the poll, I should say, that would be great. All right, onwards we go. Let's talk about understanding the cause and the impact of bad reviews. I've done similar talks like this before, and in fact, I try to do them like sort of every year, and I look back at what has been happening in the mobile space. And there's a couple of companies out there that bring out very interesting reports. Data.io is Data.ai is one of them. Link is down below. It's a really interesting report where they looked at what happened in 2021, and I use that to take a look at what is happening in the mobile space and what are some takeaways that I would want to share with everybody today. First of all, just like the mobile landscape at a glance, it's just like fun to look at the data points that the data AI guys thought were particularly interesting. So compared to 2020, 2021, of course, was still like a pandemic year, but we see a lot of like growth. App downloads, not that much, but App Store spend is going up like a lot. And I don't know if the people that are in the audience, how many of them are actually depending on revenue directly from their mobile apps in the App Store, but that could be really interesting for you. As well as daily time spent per user has been going up, probably related to there's more and more that you do on your phone where you um, used to do your expense report on a mobile browser or read your email. That's all moving to the phone. So it's a third of the daily working hours. So that's that's interesting to think about. Mobile ad spend. Now, for those of you that do have a mobile app that are now directly dependent on the App Store revenue, mobile app spend can still be really interesting. Maybe that's where you get a lot of your revenue from. So there's a lot of growth there as well, 23%. And that would be the number 41 largest country ranked by global economies. So we're talking about like a large spend there. A lot of that, of course, is in games. That's probably responsible for the lion's share of that. Classically, games kind of do like 60% of the revenue there. And probably you have your own anecdotal experience of like the game that you might play or might try that they tend to rely on ads pretty heavily for their monetization now. So this might be relevant for some of you guys in the audience. So there's a lot of apps like the 20% growth of apps where there was over $100 million spend, which is like this magic number for technology companies, right? For SaaS, just as much. So all of this is showing that the mobile space is not just like growing in revenue at a linear pace. It's speeding up. Well, you can see that based on these numbers, but believe me here. So, what are some of these things that are driving these trends? So what the slide says, ratings run the show, and I haven't really elaborated on that yet, but I am going to now. So let me pull a couple of quotes. So these are quotes from App Figures and Apptentive that do their own yearly, monthly like reports as well. So let me read these to you guys. Thanks to additions from both Apple and Google that enable developers to easily ask their users to provide a rating, I only see this total growing faster, stores relying on it more for discovery, and consumers relying on it more as a measure of popularity. If you have an app or game out there, you'll need more ratings to stay competitive. The context that I should add is that this person obviously is talking about ratings, App Store ratings, right? New App Store ratings, this is the second quote, have become the most critical signal for rankings and will continue to lead importance in 2022. This means that to rank higher, apps need more new ratings, not downloads, not revenue, just ratings, not keywords either. So that's from Apptentive, end quote. So why should you care? Okay, there is a clear narrative being presented to you that ratings are important. There's two quotes. But I'd like to, ground that in a couple of pieces of data. And this is from Apptentive again. They've been running this poll for a number of years, and every year I see very similar results. So, in order for your apps to be downloaded, it's linked to your ratings. Ratings are really important. And what's the data point there is like this quote from Attentive is when we asked, the consumers were clear that the lower the star rating, the less likely they'd be to download the app. The opportunity cost of a star is huge. Moving a 3-star app to 4 stars, for example, can lead to an 89% increase in conversion. So the narrative or business case that I present to you is a clear one. Imagine the situation that you've worked really hard on an app, and after a week in the App Store, or after like a new release or something like that, because App Stores are smart to have like the reviews per release as well. There's algorithms behind that. But imagine seeing your adoption numbers plummet. Like users are leaving and not new users are coming in. That's not what you want. And imagine that going to look at the App Store for your specific app and seeing these 3-star star ratings and just wondering how did that happen all of this the sudden, right? So why did I go from a 4-star rating down to a 3? Uh, which in this case would have directly led to a lot less new users streaming into your platform. So what's really important here is to like even if you're in that situation of having 3 stars, to take a look at what the cause is of these bad reviews. What drives these bad reviews? So I have two different pieces of information here. I see that links are not exactly at the place where they should be, but the one to the left is from the Data AI report. The one to the right is from 2016 study on like basically app stores and indexing what various reasons for low ratings were. On the left-hand side, we very clearly see basically I circled it or squared it, highlighting basically the things that impact bad reviews. So, like whenever you see the red bar, that tends to be a negative review. And we see things like every time, please fix, doesn't work, keeps crashing, try again, stopped working, won't open, take for. So you kind of see what the theme is here. So people are writing bad reviews because their app doesn't work. Now, that's probably not really what you want. Like you probably have different support channels, and this is where this poll that's running comes in. Where I'm curious amongst the participants here on this webinar, what are you guys using to actually collect customer feedback? Because app stores, you can get information about your users having problems, but your feedback loop is going to be long, and that means that you'll have negative reviews, which is going to drive your user adoption down. So that's why there's such a large industry on not having bad reviews. And some of that is driven by creating more positive reviews. There's a whole business for that now. It's called App Store optimization or something like that, after search engine optimization. So one of the ways is indeed to collect a lot of positive reviews. Obviously, that's not what we're going to talk about during this webinar. Just before I move on, let's touch on that table to the right hand side. Similar information comes to comes to us. Um, It's a little bit more like dense of a table where they're the most frequent and also most impactful, but I'll summarize it for you guys. There are different reasons that are the number one drivers of users leaving bad reviews, things as like privacy and ethical and feature removal, which is not relevant to what we're talking about now. But everything that is highlighted in those red squares are things that are related to errors, hangs, and crashes of your app, and even like resource heavy, which is one of the things that you want to report on as well. So for both of these things, imagine that you would ideally not hear that by looking at your App Store reviews, right? Like there is not like a direct line to your Slack channel the moment that you get a 2-star rating. Maybe there is. I haven't heard of it. It's not a common thing as far as I know. But it's not embedded in your workflow at all. So you have to like keep an eye on that. And it's hard to track. It's hard to create bug reports out of that. Often it doesn't have the information that you need to actually fix something, right? So the problems with this are obvious, and the impact of this is based on this data also obvious. This is going to cost you revenue and customers. So what do you want? You want to cut your error resolution time in half because errors are still going to happen. Like, you never prevent that. And of course, by doing a lot of automated testing, using devices in the Sauce's real device cloud to make sure it works on actual devices out there, old versions, you try to have as little problems as possible. But still, you are going to have problems and you have to respond to them swiftly to prevent these problems in the app stores. And that's really the focus of this webinar. You're going to have errors. Now, how do you cut your error resolution time in half? In order to talk about this, I want to like ground it a little bit more in talking about error monitoring, crash reporting in production, and also across the software delivery lifecycle. Let's wait for this slide to build. Cool. So what we're looking at is obviously an entire software delivery lifecycle. I just said that. And classically, when you're thinking about errors, you're really thinking about that development and integration like slice of the pie there. What we're looking at a lot more is not as much like the top half. There's a lot of things, products that Sauce Labs has, and also like other products out there that help you to create good releases, good apps that works, right? Like I said, test automation, doing tests on simulators and real devices, automated tests, all very important. But I'm really looking at the bottom half. So how do you take these insights of things that are happening in production, and how do you feed that to development? That's really what we're talking about, because you want to fix things and then push it on and then have these problems fixed in production as quickly as possible. So in the bottom right, you see error reporting. So this is one of the very important things in production, that things are going to happen that you didn't foresee. Just look in your own experience. It's always going to be like that. So what we're taking a look at, how can we make sure that these errors are captured, that you can prioritize, and that you can resolve them. So feeding that information from production to development and creating a really fast uh, feedback loop to be able to handle these serious problems that users are seeing. What the outcome in this case is that your cycle of fixing these things is so fast that the bad reviews are not really going to happen. And in fact, it is actually a way to bond with your customers. So think about, I don't know how your personal experience is, but I like being like sort of a user of a platform that's growing really fast, and I understand that there's going to be problems, and that can be like maybe like a new hip financial crypto something, or it can be like a new game that came out. um, but if there's a serious problem, I'm going to stop using it, right? But if there's a serious problem and I see that it's already been tagged, that I get like the information that the problem that I have has been seen before, or even better, there's an update waiting for me that fixes that. That increases like my brand loyalty a lot. So we're going to talk about mean time to detection and resolution on steroids to a really fast and powerful. How do companies do it today? Again, fill out the poll. We're curious how you guys do it today, but we generally see that there's some kind of data capture in unconnected stores. There's an issue tracker over there. Bob has an Excel spreadsheet. There's like maybe a database in some kind of tool where you're collecting certain information, like maybe your app store hangs and stuff like that. You've got your iOS over there, your Android over here. Then there's a process of manually triaging, grouping, and prioritizing these new issues, right? Like while looking at these unconnected stores, which partially is just like part of life, right? You're going to get um, information feedback from different sources. But by and large, it would be really nice if you have one store that is the most reliable, that gives you the most context, the information, and the metadata, so that you can link it from whatever comes from these external sources. You have symbolication to make the crashes human readable. It gets like a little technical, but errors are easy, right? But when it comes to some hangs and as well crashes, it is actually really complicated to give a call stack like where did this problem occur, because generally as these apps are built, all that information is stripped away. So just by looking at a crash file, you tend to not have that information. So it is usually there's some kind of process to make the crashes human readable. Often it's a manual, like you download the crash dump there, you add some debug files there, and then the developer can see what's going on, right? And there is, of course, the practice of asking customers additional details. That's why you have tickets. That's why you connect with them. Like maybe not an email, in-app messaging is a lot better. But there's still like an interaction. Like you have to ask something, you have to wait for that. That user is in a different time zone, et cetera, et cetera. So these are all very good things, but there are also things that are better. So if you really want to reduce your MTTD, which is your mean time to detection, by 90%, it is really essential to, and this goes for capturing the errors, the hangs, the crashes, like all of these different things. What Sauce Labs' Backtrace product provides to you is low-code open source SDKs for Android and iOS that you can embed into your apps, right? So these SDKs have one job, and that is to collect the occurrence and relevant context for handled exceptions, unhandled exceptions, hangs, crashes, and more types of events, right? It's customizable. So what that means is that whenever you get an error report, you can use that SDK in such a way that there's no more back and forth, that you don't have to like guess to some of the details of what that customer was doing, or what kind of device they were on, or where they, which screen they were. Like this stuff is captured automatically. And what is also like really important is for it to be scalable, because if you have endpoints collecting these types of crash information, then generally if it's like free or like included by the platform, um, those companies decide what like the rate is that you get your information. Like if you suddenly have a spike of a lot of reports, it can take minutes to hours to actually get to see like the contents of the report. Or some of the reports will be thrown away because you're running out of space. Or maybe the app can't even submit the report because the endpoint is busy. So long story short, it is really important that these crash reporting systems that you send these reports to are very scalable. So if you have like some kind of spike, something that happens, this is particularly important for like the game studios that use Backtrace, right? That can have huge spikes of players around launch time and stuff like that. But you need a platform that allows you to still see information when you have like such a storm of errors, right? To not go down. Cool. So I'm going to demo Sauce Labs' Backtrace product, which is a crash and error monitoring capture solution. So we're going to see how Backtrace allows you to do that. Now, in no means I want to say that Backtrace is the only way to do it, but um, it is important to know that even the smaller studios, or if you're an independent app developer or something like that, you might be concerned about, you know, embedding this into your app, the overhead, the costs associated with that. So one of the things that we find really important is that we are being used by the larger companies and the independent companies as well. So we have a developer's tier. So that means like if you're a smaller independent app developer and maybe you don't have millions of users, you can use this product for free. But a lot of these things that I'm going to talk about are just practices that you can implement in different ways as well. So look beyond the product that I'm showing to you. I recorded a video here of integrating. So this is the capture step of integrating this into an iOS app. So all that you need to do in this stage is to create a pod file. So our library, the Backtrace crash reporting library, is imported as a CocoaPod. As you know, many of these libraries are. What you need to do is to make sure that you have the latest version of CocoaPods, and then issue a pod install command, and that creates like all the scaffolding and infrastructure for Xcode to load it. So you might already be using CocoaPods. In that case, a lot of the scaffolding is already there. Well, long story short, whenever you've generated that and you reopen your XC workspace, what you're going to see is that separate from your app, our framework will be built as well, which does the threat reporting. There's still a little bit of code that you need to add in order for it to start collecting errors. You see a URL and a token that comes from your Backtrace instance. So the moment that you're a customer, you can find that in project settings. And you, of course, need to do some imports here. So these are reasonable defaults that are just directly copy pasted from the integration page, right? What I'm going to show you as well is separate from just like the crashes that are captured automatically, as well. And the video is going a little faster than I'm talking. As well, let me rewind a little bit. Let me pause it at like right here. So what we're seeing here is that you can explicitly include additional metadata here as well. So we see like the Backtrace client that's explicitly catching an error and sending that. You see that I could attach more metadata, such as attachments and stuff like that. That's what I quickly wanted to highlight. But the important part is the moment that you initialize that library, a lot of things are just automatically captured in the background without you having to provide any configuration for it, such as out of memory settings or out of memory events and things like that. Let's go play the video again, and let's go and take a look at Android. So like iOS, we saw the app starting just by clicking that and clicking the arrows. The arrows would be being sent to Backtrace. We're seeing the same for Android now. In this case, we're just adding a Gradle dependency. So for Android, it's a Java library basically with some native code in there as well. If you're watching this video, probably 3.10 is not the latest version anymore. So make sure that you have the latest version of that library. And it synchronizes, downloads the library and the dependency it has. And just like for iOS, what we need to do is include a little bit of code in your app to initialize the Backtrace library. So in the same way here, we're going to have a Backtrace client that we have initialization code for. I pasted that from the project settings. So if you have a Backtrace instance, you're signed up under project settings, you have that information that includes your URL and your token. And these, for the rest, are pretty default settings, right? So capturing hangs, capturing native crashes, as well as like maybe unhandled exceptions. All of these things can be enabled. We're going to, just like for iOS, capture one of the errors explicitly. So a lot of stuff is captured in the background automatically, but in this case, we're catching this arithmetic exception explicitly. And the purpose of doing that is to show that you can add additional metadata. So for iOS and for Android, you don't have to put that up right here in the code, right? You have also callbacks where you can do that, which would more really be the normal programmatic way to make sure that the backtrace references are all over your code base. That's like kind of beside the point here. The focus here is if you have a specific set of metadata that you want to add, we're adding like a key value pair, like a webinar, like what I'm next gen error reporting. That it's really easy to add that metadata. That can be really important in your error resolution steps and even your prioritization, right? Because this can give custom metadata that you might need to resolve these errors. So we made sure that the app has access to the internet, and then this is just a simple app that what we can do is trigger a hang here, which means that the next button right now works, but if we click on hang, so it doesn't really do anything. And that's the hang, and that will be reported to Backtrace automatically, as well as you see two other pretty buttons, crash and error. So click on those momentarily, and those will be like sending other exception types. So crash, you see, completely exits the app. Some errors can be silent, right? In this case, the user can't see the error, but it could be a pop-up or something like that. So cool. Let's go back to the slideshow. So next, we were ahead of our skis before. We're going to talk about improving your signal to noise ratio. So making the prioritization a painless task. So what we just saw, right? Like I recorded 2 videos because it's kind of hard to do live. The rest will actually be live demoing. Um, well, you guys are watching a video of me doing that live, so I guess that you just saw a video inside a video. So it gets kind of meta. Anyways, what I will do, at least for this recording, is do the rest live. The focus is like we've now added the code to our apps to make sure that all these events are sent to Backtrace automatically. We're now going to see as all these like hundreds and thousands of errors come in, how we can make prioritization a painless task, because it's great to have data, but you need to be able to interpret it. So how do we do that? We're going to look at automatic deduplication. We're going to look at multiple platforms in one view, bidirectional workflow integrations, Jira, Asana, Slack, Discord, multiple metrics for prioritization, and making sure that we do that for millions of reports. So I flew through this, partially because I can keep going back to this slide to touch on like the different things that we're going to talk about. So let's talk first about the automatic deduplication. Right now on the triage view of Backtrace, I'm going to show you various different overviews. Why I start with that is like one of the most important things to see here is that we have 5,500 errors here, but we have only 28 groups of unique errors. So this is something that's very core to any crash and exception management platform, and that something that Backtrace does particularly well is looking at the errors as they come in from these like thousands of different devices, right? Like it's different than server side monitoring where you maybe have like very identical servers. No, these are like all these different weird Android devices that you have out there and iOS versions and stuff like that. And what Backtrace does is group them in one group that is identified by what we call the fingerprint. So it's a unique identifier. So that's the automatic deduplication that just works for you in the background really fast. And so we've seen that across tens of thousands of different devices. And as well, what I want to show you is that it's multiple platforms, in one overview. So you can't see that directly, but I like to show you that by, for example, showing like sysname here. So in this is an example of a game. I'll switch to an iOS example or just a mobile app in a little bit. But you see the wealth of information that can be in here: iOS, Switch, PlayStation 5, Android, macOS, Windows. So all of these different systems feed into the same project. So let's take a look at. I'll stick to native mobile crashes right now. So same situation, same amount of errors, less fingerprints, right? And what we have in this case, because it's just a simple app, it's just an app. What we'll see is this name, which is the platform identifier. We have both Android and iOS here. Seems straightforward, but it is what you have often with like the free solutions is that you have your iOS over here, your Android over here. Good luck making a connection. Let's take a look at the rich bidirectional workflow integration with Jira, Asana, Slack, Discord, and stuff like that. We already see a Jira ticket here. So whenever you have like one of these line items with like deduplicated errors, what Backtrace can do for you is automatically create a ticket for that. So this ticket is as rich as possible. So we make sure that the call stack is added to that, more detail, information about. Remember, this is a group of errors, but like, what are the application versions that it happened in? So, like, long story short, that even a developer that is not directly looking in Backtrace, but just looking at Jira or Asana or Slack or whatever you're using every day, is getting all the information they need. Cool. So we just saw the bidirectional. Well, I didn't really talk about the bidirectional aspect. Let me do that real quick. So the moment that I assign it to someone, or that I close this. I could go, for example, I say, hey, I've resolved this, or someone resolves it in Jira. That all synchronizes with itself so that Backtrace can do automatic regression detection. So if I say my fixed version is 302, Backtrace can make sure that it's actually not occurring in higher versions than that. And if you've got this embedded in your QA, so not just in production, but the moment that you hit a regression in your lower environment, so with when you're doing your QA, that will flag automatically as well, so that before you're in production, it's immediately flagged. Hey, you thought that this problem was resolved, but it's not. So that's something that Backtrace does for you automatically, and it's bidirectional, as I said. Let's talk about the multiple metrics for prioritization. That's really um, essential, right? So we already took a look at the automatic best-in-class duplication. That is obviously really important for prioritization. But we also have problem-free versus users that are experiencing this problem. And to demo this a little bit better, I'm going to show you the overview page that centralizes around showing what's healthy instead of just what your problems are. Like one of the things of like your app being observable is, of course, it's telling like what the problem is and why, but it's also important that the app tells when it's healthy so that it's doing what it needs to be doing. The Backtrace SDK helps you to do that by having error-free metrics embedded in it. So it basically, as the app starts up and the user is happily doing things in their session, this information is actually captured. So we see, for example, that one specific version here has a lot more errors than other versions. We see overall that the error-free application launches is about 95%. 97% of the users are actually error-free. So by and large, my app looks actually pretty healthy, except this 2.10 version. There's something funky going on, right? So the amount of affected versus problem for users is really what we're talking about here. One more aspect that I wanted to show of that is the releases. So for apps in particularly, you're going to have multiple versions of these apps running at the same time alongside each other, right? So what you see here as well is that Backtrace can track the individual version that a user was running, and so you can also see like this version was healthy and this other version may not be. So we clearly see for this 2.10 version, for example, like my user adoption is about the same, right? My user base is just spread pretty evenly around these four versions, but I do see that there are less error-free app launches, so more errors, and less error-free users. So that is important information to prioritize, really. So if I go back to triage real quick, because we're going to look at different information, just having these like raw amounts of errors, like, and even the buckets is not enough. You also need to know how many users are being affected by that. Sorry, this is the users and how many sessions are being affected of that. So that is essential to prioritize because overall you could say, oh, 1,200 errors, that sounds pretty bad. But 98% of my users are fine, so maybe it's not. But if you would want to dig deeper, because it can still be a problem, and if you ignore individual users, that's also not a good thing. They can be users that spend a lot of money with you, or like have some kind of influence in whatever the industry you're in. So let's take a look at that. Now we've seen the amount of affected versus problem-free users. Let's take a look at grouping by device, version, platform, and more. We have an Explore view. This Explore view is really focused on um, allowing you to really drill down. So we already saw that there's something going down with the 2.10 version. So what Backtrace can very clearly show you is that for this specific version, I had, 12,000 launches. And of that, only, or 1,600 were affected, which means that the error rate is a lot higher than for my other versions, right? It's not just one error, right? It's a higher rate for all of the errors. And that's where things get a little bit more complicated. If it's just one error that happens a lot for one version, it's kind of easy. So what does Backtrace do to allow you to, zoom in on what the problem might be? It allows you to pull in a lot of like different attributes. Some of them are standard ones, like for example, process age is good to look at. That's a positive number. So an operation that we have is a bin view, and that can be your custom attribute as well. So what we see now is compared to the other version, for this version, the problem is in the beginning. So when the app just launched, I have a lot of errors, and for the rest, not really that much, right? So what are other things that I could take a look at? Maybe I'm keeping track of like where in the release stage it is. Is it in QA? Is it in production? In this case, it doesn't seem to be related to the problem because for 2.10, like it's about even. Maybe it's related to iOS versus Android. So I do a distribution of those and I see that there's a pretty even split, 50-50. So all of these types of information, some of them contain hints on what's going on, right? Like the process age, but some of them just do not. What I can keep doing is keep zooming in on various things. So, for example, I can zoom in on host name. Are there particular devices that are affected? And in this case, focused on host name. And there is, because you see very clearly, and as I click on this, that there is, what is it, 10 to 12 host names that are particularly affected by this, right? As an aside, see as well as that the actual host name in this case is obfuscated, right? So that is also something that you can embed in your SDKs through code to make sure that you're GDPR compliant, but that's an aside. Cool. Let's connect back to what we just saw. We saw a grouping by device, platform, and many more to get insights to where that problem is happening. And we now know that it's just like 12 devices that affects it, which is essential to know for your prioritization. Flame graph. Let's take a look at a flame graph. Flame graph shows you what are the paths in your code that are most volatile. So this is not the largest project. So in this case, the insights are a little limited. The only thing that we see is that there is a common stack that then splits out to these two different branches. Often this flame graph is very useful when we're taking a look and we're debugging hangs, and which are indicated by error type. In this case, there's one type of hang here, so it's not super interesting. But imagine that you're using an ad library. And in that case, it would show you very clearly which are the hangs that are related to a path that dives into that ad library or a third party library or something like that. So just showed you the flame graph and where that's useful for. I've shown you a lot of aggregation that is being done, right? Like over hundreds of different sessions. Um, but what if I want to focus on one of my particular, in this case, for example, hosts? So I want to look at this specific host, and maybe like they have been active for a number of time, but maybe I want to focus on an individual session. So I want to say, like, I don't know, this session has 12 errors, right? And I want to see, I just want to see what happened there. I can filter to that. So you can do that anywhere in Backtrace. It's like basically select these attributes, they get moved to the top. So every ounce of data that I'm seeing is related to that. And then I can switch to a list view that shows it to me in a chronological order. So now I can see, and then I can like drag in, for example, the error type. I can see that there were certain types of events, an exception, and two hangs led to a crash, another crash with the same fingerprint. So it shows me that what this user has been doing, right? And they're probably pretty frustrated by now because it keeps ending up in a crash. So we see also that this total session only lasted that long, from what is it, 8 o'clock in the morning to 8. Oh, it's still an hour. That was a patient user. But you can imagine that it's really important to be able to zoom in on an individual person as well to see how their experience was. So if I go back to our overview here, just the ability to zoom on individual sessions is also really important. Not just having that coarse grained, but having it fine grained as well. The last point I can't really demo in like a limited demo environment, but aggregations of millions of reports with minimal lag is what Backtrace is founded on. So our database is particularly focused on, you can throw anything you want at it. We have all the controls to make sure that UI keeps performing, that your data doesn't explode and stuff like that. So, however, how successful your app or your game becomes, like with Backtrace, you are sure that you have that scalability. Cool. let's go on. So cool. We've detected something now automatically. We've prioritized it. Now let's fix it. So we've seen with our game studios and app developers that we work with that the mean time to resolution can be reduced by over 50%, right? And that is very, very important to keep your users happy and resolve the problems faster. So we've already seen or established that during capture that there's an automatic collection of relevant error and crash data. But let's go ahead and let's take a look now at what that crash information all contains. We're also going to look at like the rich debugging metadata, attachments, deobfuscation, symbolication, and the metadata, what breadcrumbs are, the source code integration, and automatic scrubbing of personally identifiable information, which I already like touched on a little bit before. So let's take a look and let's pick a hang. And what I'm going to do now is I'm going to view that in the debugger. Because let's say that we've decided now that this hang is important. It's a lot of users that are being affected by it, and this is the one that I want to fix. So now I can like put my developer hat on and be like, okay, so what is the information that I need to find out what this user was actually experiencing? A lot of these errors would be possible to resolve by the context of just seeing what's going on. Like developers are great at reading call stacks, but I want to talk about various aspects of that. So back to our overview here. So automatic collection of relevant crash information, right? So what we see is obviously the call stack. This arbitrarily, we're looking at a hang now. So for a hang, what Backtrace does is it captures all the threads and then highlights the one that is hanging. And that's just true for iOS and for NDK, so in C++ apps as well that are running on Android. And what we get is a lot of attributes. So attributes that have information on was like the device in airplane mode, what was like the free amount of memory, what was the screen orientation, all kinds of these things, right? So that stuff is all collected automatically. So let's take a look at attachment, deobfuscation, and symbolication metadata we've touched upon. So attachments, you can attach whatever you want. We noticed when we went through those videos on how to embed the SDKs, right? That you can at various stages, just in a global, like just globally for every error, but also for individual errors, attach attachments. These attachments would show up right here in Backtrace. So those could be screenshots, movies, save states, things like that, and they're very easily downloadable here. So that's wonderful. What's important to know is as well that there is an automatic like cleanup process behind that. You probably don't want the attachment of like an error like 30 days ago, but you do want the statistics of that the error happened. So that is something that's provided as well. Let's talk about deobfuscation and symbolication. So right now, what we're seeing is a very readable stack. Sorry, and that is because it's a Java stack, and Java tends to give error information that's pretty well readable. So that's great. And actually, uh, for Java, this is not as much of a problem, but it is more the problem when we have a native crash. I'm going to go slightly out of order because I want to show you real quick the source code integration before I move on. So you can connect your Git, Perforce, Plastic SCM, whatever repository to Backtrace, and then we can link whatever we see in the call stack automatically to the code. Like in this case, it's kind of obvious what the hang is. It's probably pretty easy to fix, but it's even so that developer doesn't have to pull open their IDA to take a look at what that class exactly does. And this would be able to take in account specific revisions as well. I'm showing master now, but if this is done under a specific tag, we would have pulled up that specific tag. Now let's take a look at a native crash because there are a couple of things that are very different for a native crash. So in the native crash, the rest of the context of the app has stopped working, right? So this is an iOS one. Let's stick to Android if we can find one. Well, let's not try to find one. Let's just use the filtering to actually select one. A lot easier. So for this Android error, what we see is a combination of different elements in the call stack. So first of all, you see all the threats that are out there. So everything like that is captured. And we see as well like some of the native libraries, like for example libc.so, they're symbolicated as well. So instead of seeing like this hex code, there's actually a reference to the function that was being called. And this is done through client-side unwinding. That's part of our Android SDK, and iOS does that. iOS Crash Library does that as well. But this is where I want to call out the importance of symbolication. So when you build your app and the app crashes because it's native code, a lot of the information on the call stack is not available unless you load the debug symbols. So developers are accustomed to downloading the dump file and finding their debug symbols, and that's basically something that Backtrace does for you automatically. So as part of your CI/CD, when you're building your app, you can upload the symbols to Backtrace, and it combines that automatically, so you can actually read what's going on. Because otherwise, you would see just one stack with all the kinds of these hex addresses or that are not really that useful to you. So the focus here is to present something that's immediately actionable to a developer. That's for deobfuscation as well. So if you're using ProGuard to like mangle up your code, so protect your intellectual property, we can unwind that as well if you provide the mapping files to us. Already touched on the device metadata. Let's take a look at breadcrumbs. So breadcrumbs are very important to see how did the user get to the error. There can be custom breadcrumbs that you add from native code, if you're making an NDK app, or from Java. That's both of them are possible. And there's a lot of system events as well. If you switch app and stuff like that, that's added automatically to the breadcrumb trails. So this can be really useful if the error is like a memory problem or something like that. And by just looking at this report, it's not immediately obvious what the problem is. Because in that case, what you could do is with Sauce's real device cloud, is actually spin up that exact same device or same iOS version, and based on the breadcrumb trail, replay what that user did, more or less, and see if you can get closer to what the actual problem was. So that comes to breadcrumbs, what user actions and system events have occurred prior to the issue. Source code integration, I went out of order there. We saw that. This works for other languages as well. So I showed it to you for Java, but it works for C++ code in Android as well, and Objective-C and Swift as well, obviously. I already touched on automatic scrubbing of personally identifiable information when I showed you the prioritize overview, but we can see it here as well. If I go to attributes, and I hope your eyes are better than mine. There's a host name here. There it is. We see, or we can barely see probably, that this is an obfuscated host name. So that is something that you can configure in our SDK. Another thing to be aware of is that generally when a crash dump is collected, that crash dump can contain more information than you technically want. For example, what you often have, well, not in this case, but like, for example, environment variables and stuff like that. These are things that Backtrace, upon receiving that crash dump, will immediately filter out. So that means that our database remains void of PII data, which means that all your developers can look at that, not just your lead developers, and that's really important. So we've touched upon that automatic scrubbing of personally identifiable information. Wonderful. So if I would recap this, I would recommend using best-in-class error and crash reporting for your mobile apps to make sure that your app store ratings do not become the place where users come to complain, because you fix the problems faster than your users get frustrated. Hopefully, that it's important to have a full life cycle of automated crash and error capture to keep in mind that you're in like a life cycle, that whatever you find needs to be fed up back into development. It's not just on an island. That it's truly cross-platform for mobile and for any other devices that you might have, server-side technology as well. That there's a purpose-built database technology for analytic workloads and app stability. What that means is just basically that it performs well and it can handle all the data that you throw at it, purposely built for that. And also, what is essential is that you want it integrated with tools like Jira, Slack, Teams, GitHub, whatever you use on a day-to-day basis. I haven't really talked about that much about like forwarding the metrics from Backtrace to a Datadog, but like know that that is very common as well. Like for observability, you can see Backtrace as an expert system. It knows everything about like crash information, but like the statistics and metric that it captured, it can forward to your centralized observability platform as well. Cool. Um, and all that remains to us now is Q&A. And of course, looking at the results of the poll as well that was running. So I am curious what the questions are, and I'm curious what the poll results are.